Okay, so chapter 4, you guys know scripting. In fact, you even know published scripts using the double percents. I hope you guys have been getting used to that throughout the semester and finding out all the little tips and tricks and things that can go wrong or not go wrong. The double percent creating a headline, but a script is basically a list of commands that you would execute to Matlab. You guys are pretty well used to that. You can put the input statement into a script, and I think you guys did that too. And you know, I forget exactly how it worked. This might be useful for your exam if you're going, oh, scratching your head going, gee, I forgot this. You can always issue a help command. What do you do? So input's pretty easy. You just something equals input. It's whatever you type on the keyboard gets to the input. Okay. Now let's see. Editor. I minimize the editor and then I don't know where it went. There it is, over here. Editor. So by the way, you guys have noticed the minimization function. So I needed to get it out of the way for a while. I get it back in the way. And I could go input. I'm going to go X equals input range of angles. Now I can't run this as a published script like this. And I hope you guys have figured that one out through all your practices so far. Input start. Let's see. I'd have to put a start for the input. I'm accepting one input. Input INPUT DLG allows you to input several values all at once. This only allows you to input one. So here you put input start. And I'll make it a Y instead of an X. Z equals END, and I'll percent out my display and create the vector from starting it. And now here's a good place. Okay, this is a good place not to use linspace because linspace is well, actually, this is a good place to use linspace. Linspace is start end X. So the start is Y, the end is Z, and the let's see, does it even give us? No, it just gives us ABC. Start is Y, end is Z. We want 100. So this will create 100 angles between whatever we start with and whatever we finish. You can't publish this one. If you try to publish, you'll get an error because it's got an input statement in. It'll throw an error if you try to publish it. Just out of curiosity, we will try to publish it just to show that it doesn't work. And my command window will come up with, it'll try to do something. There, and it's giving me errors. Can't use an input. But I can run it as a script. So all I have to do is do my pub. And it'll ask me for the start angle, 0. Oops, let's get rid of that guy. Start angle, 0. End angle, 360. And then it's outputting like 100. Here's all the angles it's creating. And I have another angle. Or I have another problem. So I would have to fix this problem later. But it's a problem not related to the publish command. Okay. So that's scripting and publish scripts. Function files, you guys should be getting kind of familiar with that also. Let's see. We're going to do some inline functions, which is coming up here. But you know, I didn't do a myfunc. There we go. Here's all this myfunc sound makes a sign, and I don't have that anywhere. I wonder where. Oh, wait a minute. Oh, I know. Look at this. I have an underscore on this one, and I don't have an underscore here. So I made a mistake here. I would have to put an underscore in my publish file. So let's try just running the script again. There we go. I'm running the script again. I'm going to start at 0, go to 360. And this time, boom, it comes up fine. That fixed the mistake in the earlier file. Let's take a look at what myfunc is. And you guys have seen this before. Simple function. This is your output. This is your input. You can do multiple outputs up here. By the way, in your exam, you're going to be asked to create a matrix. So you're going to have to concatenate matrices. So here's the output variable here, and I just set it equal to the sign D, sign in degrees of the input. And here's the name of the function. So that's creating function files. You know, you can mess around with inline functions and stuff like that, which I'll show you in just a second here. But generally speaking, it's probably better just to create the file and do it. Let's see. There's also something called a subfunction, which can be useful in some other ways. So, inline functions and subfunctions. Right here. This would be an inline function that we're square. This is a quadratic type of equation. At inline function name, variable x, and then expression. So let me just run this section. Editor, there we go. Run the section. And so it finds the square. I don't have semicolons, so it's showing me everything it's doing. So I create the variable here, and I execute this inline function, and then I call the inline function. Here's the call. It's just like another function. Okay. We could also create the same function in a file, which is what this does, and I haven't created the file, and that's okay because you guys know how to do that by now. Here's inline. It uses the inline command. So it'll do the same thing as we did before, except it uses this command, and I'm trying to see if now this might be one thing where Matlab might basically they might not allow you to use inline anymore. In fact, I'm going to hover over this. Inline will be removed in a future release. Use anonymous functions instead. Okay. So, although you can do it, and I think you can still do it, probably a terrible practice because it's telling us, you know, you guys better do it another way because all your code that has this command in it is going to break. So I run it. It hasn't broken yet. Still works. So we know that. Handles. So I haven't created square 2. I'm just going to, I've already created square as a function. Yeah, there it is. There's my function, my inline function. Let's see if a handle will work with that inline function. It might not. Oops, I want to cancel this. There we go. It might not work with an inline function. I'm going to try it anyway. Handle. You put square might be used incompatibly or redefined. In other words, you might not be able to do it this way. This equal sign, basically it says I need to terminate with a semicolon. Throughout what we've done so far, you guys have noticed it tries to tell you when there's an error going on. So this might not work. It's warning me this might not work. I've defined it up here, but then again, it might not work. So let's go ahead and try to run you can experiment. You can always find out if it works or not. And it says, nope, doesn't work. So I need to create a square 2 function, which I did previously. SQR2. And let's see, this is going to be SQR of X, input argument X. And what was it looking? It was looking like X, there we go. So that's what we're going to make X equals. There we go. Now if I've defined this function square 2. And I can go back here and change this handle to square 2. From now on, now that I've set this handle equal to square 2, I can just refer to the handle. So it gives me a good answer. Now I can just refer to the handle. I don't have handle. H for handle. It's like an alias. It's like a shortcut in Windows, right? You guys have used shortcuts in Windows, right? Or things like that. That's kind of how a handle works. It's just giving you another way to grab the function. So now we can run the handles of the function rather than the function itself, and it should work just fine. There we go. We got a couple answers. We can do F. You guys have run in function eval of X. We can set X equal to a variable. And is X defined? Let's see. Go back to my workspace window. I think X is defined. There it is. So, yay, it works. I can just evaluate it just like it was a function. This shows us a couple other things. F0 will help us find the zeros of H square. Well, we know the zeros are at 2 and negative 2. If X equals 2, then that's going to result, the function is going to be 0. The output's going to be 0. If F equals negative 2, the function is going to be 0. This should return 2. This is a function that returns where the function is 0. There's also an min search that helps us find where the function is minimum. I'm throwing in a new command here also called profile. What that does is it helps us to see how things are working, how efficient our code is working. So let me run this section here. And this is the profile viewer. It tells us how much time is spent in this. The big dark line is how much time, 15 milliseconds in this one, 18 milliseconds in the total, and then some things inside Matlab that aren't taking much time. They're really short. So these two big things take the most time. So that's profiling. You start profile on, Profile viewer lets you see the profile. Profile off stops it.